So in this triangle, this is 4r and this whole thing is 4.5r. So this base would be 3.5r because this length is r. So this is 3.5r. If this angle is theta, then from simple trigonometry, you can see that sine theta is equal to 7/8. So this is your FPD, and in this FPD you can mention that theta is equal to sine inverse 7/8. Now if you haven't seen this inverse thing before, just know for now that sine theta is 7/8. We can write theta is equal to sine inverse 7/8. Okay, so now that is enough practice for FPD. Rest you will find more problems in exercise when you will solve it. Now we are moving on to the next section of using the things that we have studied, using the 5 forces that we studied and using the FBD that we studied. So now we'll be analyzing the static condition of bodies in equilibrium. That's static equilibrium. So we'll be beginning with simple possible case. Consider this. This is a block kept on the ground. Now Newton's first law says that if there is no net external force, if net external force, summation of all the external force is 0, then there is no change in velocity. If the body is at rest, it is at rest. If it is moving with constant velocity, it keeps on moving with constant velocity. That means there is no change in velocity. dv by dt is 0. So now what we will do from here is we will break this equation into 2 equations, one corresponding to horizontal direction and the other corresponding to vertical direction. Because whatever force we have in the form of external forces, we always break that into 2 components perpendicular to each other. So I can write this as, if the body is at rest, then the x component of all the external force is 0. And the y component of all the external force is 0 as well. So we have 2 equations now, and from here using these 2 equations we can find some variables which are not known. For example, in this case, suppose it is given that the body is of 10 kg and we are asking what is the normal reaction, how much of the normal reaction force is acting on the block. Then to do that we learn to draw FBD. So let's draw the FBD. There are 2 forces, one is mg and the other one is normal reaction. There is no horizontal force, so we will not be considering this equation. This is the equation of concern here. There are only vertical forces, so that means all the summation of all the external forces in vertical direction would be 0. So we write mg. If we take mg as positive, forces are vector, remember. You have to put it with sign. If mg is positive, if downward direction is positive, then normal reaction is negative. Mg minus n is equal to 0. Sum of net external forces should be 0. That's what Newton's first law tells us. So in this case it is stationary, so sum of all the external forces is 0 in vertical direction. That's what we have done. Mg, putting n with proper sign, minus n is equal to 0. It gives us mg is equal to n. So we have found out the normal reaction, that is it will be equal to mg. And if it is of 10, it's a 10 kg block, then the normal reaction would be of 100 Newton. Okay, so this was a simple case. Let's look at a little more complicated case. Consider there are 2 blocks, 20 kg and 10 kg. Now tell me, what is the normal reaction at this contact? To do that, we should write initially, you always draw the FBD and write the proper equations. Later you can do it orally. But now when you're building the concept, don't skip it. Let's draw the FBD. Mg in this case will be 100, m into g. And this is the normal reaction, N1. I've drawn the FBD of 10 kg block. Now let's draw the FBD of 20 kg block. Mg would be 200. Normal reaction from this surface will be upward, N2. And the normal reaction from this surface will be downward. Let us draw it like this, N1. Now I have to find N2. I have to find N2, normal reaction. I have to find this, N2, normal reaction from the ground, which is acting upward. Now to do that, I should write the equation of equilibrium. The equation of equilibrium meaning the sum of net external force should be 0. So let's write it, 200, this is the mg. If you have taken 200 as positive, if this direction is positive, the upward direction should be negative. So minus N2. And then N1 is again downward, plus N1. This should be equal to 0. The sum of all the external forces should be equal to 0. Now we have to find N2, so for that we should know N1, and from N1 if you write the equation of equilibrium for this block, you will find N1 as 100. So we can put N1 here 100 and find N2 as 300 Newton. So using this equation of equilibrium, very simply we can find out unknown forces, given that we have some information.